Hello, students. This is the homework for chapter 3. And this chapter is basically dependent on one formula. And that's the one that you see right now on the screen. The net force is mass times acceleration. That's the formula. Now, what is important is to note that it's not a single force, but it's the net. Net means total force. And since force is a vector, we will have to consider the direction of the forces. So as shown in the diagram, if you have 4 forces acting on the object, but 2 of them on the y-axis and 2 of them on the x-axis, then we got to look at them individually. I mean, you have to look at the forces on the x-axis separately from the forces on the y-axis. So if you look at the forces on the X, you see that the F at, or the applied force, is to the right side, so it's positive, but the friction force is to the left, so it's negative. So when you take the net force of these two, you're going to take F applied minus F friction. That's because they are in opposite directions. So if the applied force is 50 newtons, and the frictional force is 10 newtons, then in this particular case, on the x-axis, the net force is 40 newtons. Now, when you look at the y-axis, this is the normal force. That means when you place an object on a table, like a water bottle is on a table, the table pushes back on the water bottle. That's the normal force, a reaction force. And the weight of the water bottle is mg. So weight is always mass of the object times the acceleration due to gravity, which you know is 9.8 meter per second squared. So if the mass of an object is 1 kilogram, then its weight is 1 multiplied by 9.8, which gives, of course, 9.8 newtons. Oh, there it is. The unit of force is a Newton. So I can write that here right now. We know that the unit of mass is kilogram, and the unit of acceleration is meter per second squared. If you multiply them, what you get is called the Newton. So the Newton is kilogram times meter per second squared. So that's the unit of force. So this is what I just explained. Except I did not tell you that on a flat surface, usually the net force, the normal force, the normal force is exactly the same as the weight on the y-axis. Okay, that's what you see here. And therefore, when you take the net force, again, this is positive and the weight is negative. So one minus the other, since they are equal, you should get 0. That's on the y-axis. On the x-axis, I already mentioned and explained that you have to take the applied force minus the friction, which is the net force, and set that equal to mass times acceleration. Why? Because the net force is always mass times acceleration. See that? That's why. So net force is mass times acceleration. So once you get the net force, you set that equal to mass times acceleration. So in our example, if the forces are 50 and 10, we know that the net force is 40 newtons. If you assume the mass to be 4 kilogram, just assuming the mass of the object to be 4 kilogram, then we could find the acceleration on the x-axis. Dividing both sides by 4 kilogram will get rid of the units, and also get rid of the 4 here. The 4 will also cancel out for sure. And you'll be left with 40 by 4, which is 10 Newton per kilogram or meter per second squared. So you can have both of those units. You can either have meter per second squared or you can have Newton per kilogram as the unit. So that's the fundamental idea in this whole chapter. But then we also have to remember the kinematic equations that we had in the last chapter. So these are the 4 fundamental kinematic equations you may remember, where V sub F is the final velocity, V naught is the initial velocity, A is the acceleration, T is the time. Same factors on the right side here. Delta Y is the displacement on the y-axis. So you see all those terms repeated here. So these 3 are to be used in correlation with the new formula in this chapter, which is net force is mass times acceleration. So that is what we have. So let's go to the first question. All right, in the first question, a 500 Newton parachutist opens his chute and experiences an air resistance force of 800 Newton. You see the words resistance force, that means it's going against the motion. So the parachute is coming down, right? And the air is trying to push it up. Question is, what's the net force on that parachutist? So we have to draw what is called a free body diagram. Now, a free body diagram means you look at all the forces acting on that object. So here's the object, and we know there are 2 forces acting on it. One is the force upward. It's called FD because it's usually called the drag force, okay? DRAG, drag. It's the air resistance, same thing. And the second force is the weight. Is the weight given? Yes, that's the drag. So now when you take the net force, you got to take one minus the other. Remember that this is positive, this is negative, and 800 minus 500 is going to be 300. But you can't just say 300. You also have to give its direction. You have to say it's 300 Newton upward. So here I've introduced the free body diagram, and I've also explained how to find it. So there I've written it down. I hope you get that. That's question number 1. All right. Now let's go to question number 2. A human body can withstand an acceleration of 10g. That's not 10 gram, 10g. What net force would produce this acceleration for a 50 kilogram person? First of all, it's amazing that a human body can withstand that much of an acceleration. What do you mean by 10g? We know g is 9.8 meter per second squared, don't we? So 10g is simply 10 times 9.8, which is 98 meter per second squared. That is the acceleration that a human body can withstand. And you're asked to find what? The net force. So we start with a free body diagram here. You can see the free body diagram. That's the 50 kilogram of the mass of the person. You have 2 forces acting. One is the weight. 50 kilogram is the mass. That's not weight. To get the weight, you got to multiply the mass with 9.8. So 50 times 9.8 is 490 Newton. That's the weight acting down. And then we do not know any of this. We got to calculate it and show it. Okay. Let's do it. So the acceleration is 10 times 9.8, which is 98 meter per second squared. I've already explained that. And the weight is 490 Newton. Now, the last thing you got to do is we know that the net force on this object is its mass times acceleration. What's the mass? 50 kilogram. What is the acceleration? 98, right there, 98. So the net force is 4,900 newtons. That's why you see that in the diagram. Now, if the net is 4,900, and we know there is a force acting down, then surely the force acting up must be the sum of these two, which is how you get that. Let me show you the math. F net, is F support minus the weight, because the force on the support is up and the weight is down. Therefore, when you do the math, you know that when you add the weight to both sides, this is what you're going to get, 5,390 newtons. Here is question number 3. If you are driving at 20 meter per second and slam on your brakes and skid at zero point 0.5 times g to a full stop, how long is the skidding time? So from this question, you're given the initial velocity. You're driving at 20 meter per second. When you hit the brakes, forces are applied. That causes an acceleration of 0.5 times g. And from the last question, that means it's 0.5 times 9.8. So that's the acceleration. And then it comes to a stop. So the final velocity is 0. And we have to find the time. So in this case, a diagram, just shows the normal force and the weight on the y-axis. We're not interested about those two because they're equal and there is no motion on the y-axis. Now, on the x-axis, there's only one force, and that is the force of friction. Because when you hit the brakes, what stops the car is the friction between the tires and the road. That's why you need good tires for it to stop in a smaller time or in a smaller distance, okay? So that's the only force. Excuse me. So the force of friction is the only force. So that's the net force. So the idea is to use kinematics first. A is 0.5 g, I already told you that. And the reason why I'm putting negative, important, is to realize that the car is slowing down. So when you step on the gas, the car speeds up, but when you step on the brake, it slows down. So whenever any object slows down, its acceleration must be taken as negative. I'm going to say that again. Whenever an object slows down, the acceleration is negative. If it speeds up, it is positive. The initial velocity is 20 meter per second. The final velocity is 0, and you're looking for time. And when you look at these four, you have to make the connection that this is the equation you're going to use. V final is V initial plus AT. Plug in the numbers. V final is 0. Initial is 20 meter per second. A is negative 4.9 meter per second squared times t. Okay, so now subtract 20 meter per second from both sides, which will cancel it out here, and then you will have a negative 20 meter per second on the left side, right? Once again, do remember that this is one term, as you can see. And then the next step is to divide both sides by negative 4.9, because then the negative 4.9 here will cancel out, and here you'll be left with this. So negative divided by a negative is positive, and you get the answer as 4.08 seconds. So that's question number 3. Moving on to number 4. Okay, let's see what this is. A 10 kilogram block with an initial velocity of 10 meter per second slides 10 meter across the horizontal surface and comes to rest. Look at that statement. You got the mass of the object, you have the initial velocity, which is v naught, you have the distance it's moving. We're going to take it as delta x because it's on the x-axis, it's a horizontal surface. And you got the time. Oh, you also got the final velocity, which is 0, and the time. And you're asked to find this force. So it's always good to start with what you're asked to find. And in this case, you're asked to find the force, right? Oh, that's not so good. Okay. You're asked to find the force. So let me highlight that, underline that. There's only one formula for force. What's that? Net force is mass times acceleration. So that's the formula we're going to use. We know the mass already. So all we need is the acceleration, which we have to find using kinematics. But before we get there, here is the free body diagram. The 10 kilogram block, its weight is 98. The normal force is 98. They're equal. We don't need it, but I'm just showing you that's almost always the case. The weight is equal to the normal reaction. Once again, like in the last problem, the only force on the x-axis is friction. That is 50 Newton. Where did we get it? That's what we have to find. Okay, let me show you how to get that 50 Newton. We're given the initial velocity, the displacement, the final velocity, and the time. No need of any confusion. It's in the question. You have to read it, look at the unit, and know that velocity is in meter per second, distances are in meter, time is in seconds. Just get used to it. And then look carefully at this. You may remember this equation that we used so many times, but we just to find the acceleration, you don't need to use all of this. You can see I've used this and just 0, final velocity is 0, right? Is equal to initial is 10 meter per second plus a times 2. Then, like in the last case, subtract 10 from both sides. That gets canceled here. You get this. Divide both sides by 2 seconds, as I've shown, and you get the acceleration is negative 5 meter per second squared. Notice that you're getting negative. That's because it's slowing down. See? And once you get the acceleration, the net force is mass times acceleration, which is 10 times negative 5, which gives you negative 50 newtons. Now I know the unit is going to be kilogram meter per second squared, right? But kilogram meter per second squared is the same as Newton. That's why I have that written there. Question. A jumbo jet has a mass of 100,000 kilograms. Each of its 4 engines produces a thrust of 50,000 newtons. You got to be careful there. It has 4 engines, and each one produces 50,000 newtons. Now, thrust means force. That's another word, thrust, force. And you're asked to find the acceleration of the jet when it's taking off. So here's the free body diagram again. Notice that the normal force is the same as the weight. We don't need that. That's along the y-axis. The thrust is given as this, and that is the net force because there's no other force mentioned here. No mention of air resistance or friction. So the only force is the thrust by the engines. But how did we get that? Is that what's given? No, what's given is 50,000. Oh yeah, there are 4 engines, so you got to multiply 50,000 with 4. Okay, so there you have it. Mass is given 4 times 50,000 is 200,000 newtons. Once you get that, use the net force of mass times acceleration. So 200,000 is 100,000 times A. Divide both sides by 100,000 and then cancel this out. And then you're left with 2 meter per second squared. That's it. 2 meter per second squared. That brings us to the sixth question. These are extra questions, but important for the exam. A patient, mass is given, 60 kilogram, lies on a wheeled stretcher, mass 15 kilograms. A caregiver needs to accelerate the loaded stretcher from rest to a walking speed of 0.60 meter per second in 3.0 seconds, doing so smoothly to avoid jostling the patient. What constant horizontal force must the caregiver apply to achieve this acceleration? Okay, we will read the second part later, but focus on what you're looking for. What are you looking for? Force. The caregiver is obviously trying to move the patient, but it's not just the patient, the stretcher is also moving. So, first off, you have to take the total mass of both into consideration when it moves, right? Second thing is the only formula we know is force is mass times acceleration. So we have to find the acceleration. Here's the free body diagram. The only force is the push force, which is what we're trying to find. The answer is already here, but we're going to find it. Let's see. Okay, from kinematics, the initial velocity is 0. This is the velocity that you got to give it. That's the time. We got to get the acceleration. All right, here is the formula which connects these four. So 0.60 is equal to 0 plus A, because we don't know A, we just leave it as A, times time, which is 3. And then this 0 does nothing. So just divide both sides by 3.0 and then get the answer for the acceleration. Once you get the acceleration, multiply it with the mass, which is 75. Remember, 60 plus 15. And then you get 75 times zero point 0.2 is 15.0 Newton. Okay, so what's the second part? Second part says during that 3 seconds interval, or during that 3 second interval of uniform acceleration, how far does the structure travel? So what are we looking for now? The distance, delta x. Let's find it using kinematics. This formula. Delta x is v naught t plus 1 half at squared. V naught, initial velocity is 0, so this whole term becomes 0, plus 1 half times acceleration times t squared. Do not forget to square it. When you do that, this whole thing is 0, but then for this, you're going to get 0.9 meter. It just moves 0.9 meter, not even 1 meter. That's what it means. So here is question number 7. A patient, mass 55 kilograms, sits in a wheelchair whose total mass, chair plus patient, is 90 kilogram. So now the total mass is given as 90 kilogram, and that's what we are interested in. The wheelchair is moving at 1.8 meter per second down a gentle hallway. The nurse applies the brakes so that the wheelchair decelerates uniformly at 0.75 meter per second squared. What magnitude of braking force does the nurse's action exert on the wheelchair? So once again, you're looking for force, and we just need the acceleration and the acceleration is given. Notice that? So you have the mass and the acceleration. But because it's a deceleration, we should take it as negative. So once again, we know we got used to this free body diagram. The only force on the x-axis is the friction, which is what we're trying to find, and it's surely 90 kilogram times negative 0.75. Why is it negative again? Because it is decelerating. It's slowing down. Whenever an object slows down, the acceleration is taken as negative. Okay, so we got the force. What's the second part? How much distance does the wheelchair cover before coming to rest? So there, right there, you have the final velocity as 0 because it comes to rest. We got the initial velocity here, and we also have the acceleration. So back to kinematics. This time I tried to print it out instead of writing it. Actually, I had to write it and then change it to print. So I did pay the price for that with some errors. So this part has been repeated. So I'm going to scratch that out. So what is given is the initial velocity. The A is negative. Final velocity is 0. And we're looking for the distance. The formula to be used is Pf squared is equal to V naught squared plus 2a delta x. So that's V naught. And then when you carefully substitute, you get 0 is equal to the initial is 1.8. So put that there, plus 2 times negative. So that should be negative 0.75 times delta x. So when you take these two, remember this is one term. So 2 times negative 0.75 is negative 1.5. So that's one term. And then this should be a plus here. So plus, okay. And do not forget to square this term. So square this term. And then when you rearrange it, you're going to get 3.24 because this is going to be 3.24 divided by 1.5, which gives you 2.16 meter. Okay, so that's what you get when you do the math carefully. Okay, now we go to number 8. A hospital elevator must raise a patient on a gurney. The total mass is 100 kilograms from the ground floor to the first floor at a constant upward acceleration of 0.80. So that's the acceleration for 2.5 seconds. That's the time. So you have the mass, you have the acceleration, you have the time. What upward tension? So when you see the word tension, that's another word for force. So thrust means force, tension again means force. So what upward tension must the cable provide during that 2.5 second interval? All right, so here is the free body diagram. The tension in the cable, that's what we have to find, and I've already found it. But we know that the weight is 980 newtons. How do I get that? Because weight is mass times G, 100 kilogram times 9.8 gives 980 newtons. So that's how I got the weight. We don't have this. This is what we're looking for, but we have the acceleration. So we can use the net force. Okay, watch this very carefully. This force is up. This force is down. So T minus the weight should be equal to ma because net force is mass times acceleration. Or let me write that. The net force is mass times acceleration. And in this case, the net force is T minus the weight. So if you add the weight to both sides, you're going to get T is equal to MA plus the weight. And so substitute that, mass times the acceleration plus the weight is 980. Look at that. So when you do the math, you're going to get 1060 newtons. Please ignore this. This is because I paid the price for changing the handwriting into text and it messed it up. Okay. Excuse me for that. Now, what's the second part? How far does the elevator travel or move upward in those 2.5 seconds? So back to kinematics. You're given the time. You know that it started from rest. You have the acceleration. And we are looking for what? We're looking for how much did it move? So we're looking for delta y. So we're trying to find delta y. And the equation that relates these four is right here. And then 0 multiplied by anything is 0. So I did not even bother writing time there. The whole thing is 0 anyways. And then you have 1/2 times a right there, t squared. So once again, do not forget to square this. When you square it, multiply it by 0.80 divided by 2, you're going to get 2.50 meter. So from the ground floor to the first floor, it only moved 2.5 meter. Okay, so those are the two answers. All right, let's move to the next one. Next, the ninth one. During a rehabilitation exercise, a therapist asks a patient to lift a prosthetic leg segment, mass 6.0 kilogram, from a horizontal position to a vertical position. Okay, so this is being lifted up now. The therapist applies the force so that the leg segment's center of mass accelerates upward at 1.00. Now, don't worry about center of mass and all that. Just know that the object accelerates at that rate for that much of a distance. Assume that the leg segment starts from rest and moves in a straight line up. Question: what upward force must the therapist exert? So again, force. And what is force? Mass times acceleration. So the this is again movement on the y-axis. We're looking for this. We don't know this. We're looking for this. But we know that the weight acts down. So when you take the net force, like in the last problem, we can calculate this force. But before that, you remember that weight is m times g. I've said that 100 times now. So 6.0 times 9.8, get the weight, and then take the net force, which would be F minus the weight forced by the therapist. That's this one, minus the weight is MA. If you add the weight to both sides, this is what you get, exactly like in the previous one. And then mass times the acceleration plus the weight, which we already found. See that? And you get the force applied by the therapist as 64.8 Newton. What's the second part? What is the final speed? Final speed means final velocity. So you're given initial speed, acceleration, displacement, and you're looking for what? The final speed, okay? And the formula that relates these four is this one. So that's use Vf squared is V naught squared plus 2a delta y. Substitute carefully, 2 times a times delta y comes out to be exactly 1.00. That is a square, but take the square root on both sides. Square root of 1 is just 1, so we have the answer. Now we come to the last one, and am I glad? I am. Okay. A handheld surgical instrument could be a pneumatic drill bit of mass 0.60 kilogram, has a tip that is moving downward. Now remember, it's moving down at 2.5 meter per second when it hits a bone surface. The surgeon must bring it to rest over a distance of only 0.5 meter to avoid penetrating too deeply. Assume the deceleration is uniform over that distance. What is the magnitude of the average deceleration required to stop the instrument? Okay, so that's a kinematic plot. Now, before I show you, let me ask you this. What is the initial velocity? Can you tell me what the initial velocity is? Like I don't hear you, but you can say it loud because you can hear yourself. Most of the time, students get it wrong, but it's okay. If you set 2.5 meter per second, you're very close. But remember, it's moving down, and anything moving down is negative. Remember that? Now you do. So it's negative 2.5. And then we have the distance is 0.15 meter. Again, it's moving down, so that's also negative. The final velocity is 0. Why? Because it says the surgeon must bring it to rest. So we have the initial negative 2.5, final velocity 0. We have that displacement, you're looking for A. So here are the quantities, I've listed it down. See the negative on this and the negative on this? Once again, because they're moving down. Ooh. And this one changed the question mark to 7. Goodness. Okay, so we're looking for acceleration. And the equation that relates these four is the one that does not have time in it, is this one. Now carefully substitute. When you substitute, you got 0, negative 2.5 squared, right? Plus 2 times A, which we do not know, times delta y. Now this is one term, so you multiply this with 2, you're going to get 0.30 A. You have to leave A as A because you don't know its number. And then this, when you square it, when you square a negative number, it becomes positive. That's why it's 6.25. Next step, add 0.30A to both sides. It'll cancel out here, so that's why you have this. Last, divide both sides by 0.30. This messed up again. This is 6.25. I'll never do this again. I'll just write it. Okay. So 6.25 by 0.30 gives you 20.8 meter per second squared. That is the acceleration. Last, what force must be applied? Now, once you get the A, you just multiply it with the mass. What's the mass? Right here, 0.60. So multiply 0.60 kilogram, multiplied by 20.8, and you get 12.50 Newton. Now, these are 10 very important questions. The first 5 are related to your homework, and the last 5 are for extra practice so you can do good on the exam. Hope it helps you. Again, post it in your comments how I could make it better. And, encouragement is a must. So thank you. I'm encouraging you to do your best. Thank you. We'll see you on the next one.